Hi, this packet is graphing equations. So I'm going to minimize myself so you can see the whole page. And let's get started. So becoming familiar with a coordinate grid. You may have done this probably back in middle school where you had to graph the x coordinate and the y coordinate. So how that works is you have a coordinate x and you have a coordinate y. And x is how far left or right a number is on this number line here. It's called the x-axis. And x is how far to the left or to the right of 0 the number is. So if the x value is negative, your answer is going to be to the left of 0. If your x value is positive, it's going to be to the right of 0. The y value up here is how far above or below 0 your number is. So just take another color here and draw this way. This is your y-axis, the blue line. So if your number is positive, your y value over here is positive, your numbers will be above 0. And if your y value is negative, your numbers will be below 0. The more negative your numbers, the farther from 0 you are. The more positive your numbers, the farther from 0 you are. And 0 works right in the center here. This is 0, and that's 0 for the x-axis and 0 for the y-axis. So they call this the y-axis. So for instance, if I was going to plot point A over here, -6, 4. The -6 is my x value. That's how far to the left or to the right the number is from 0. So -6 would be 6 units to the left of 0. So 1, 2, 3, 4, 5, 6. And then the 4 represents how far up I go. Because it's positive, I'm going 4 up. 1, 2, 3, 4. And you'll notice that right here is plotted the point. B is over here, and the values, the coordinates are 6, 4. The x is 6 units to the right of 0, and then it's up 4. 1, 2, 3, 4. That's B right here, where they meet, the lines meet. And then if I was to plot C, which is down here, again, it's 6 to the right, and then the y value is -4 this time, so it's 4 units below the x-axis, or 4 units below 0. 1, 2, 3, 4, and then it gets put right here. And then we go over to D, and the value is -6, -4. So -6 is how far left I am of 0, and then -4 is 4 units down from 0. Each quadrant has a number. This is always called quadrant 1, and it's designated with Roman numerals. This is quadrant 2. This is quadrant 3. And this is quadrant 4. So if I was to ask you the point -6, 4, which quadrant would that be in? You would say quadrant 2. That's the A point here. Okay, that's how a coordinate grid works. So this packet begins by having you determine which is, write the pair as an ordered pair. So basically all you're doing is rewriting the numbers they're giving you in the right order. So this is your x value, this is your y value. That is to cement in your head that x comes before y on the coordinate grid. And you can think of it alphabetically because x comes before y in the alphabet. So B here would be -3, 5. What quadrant would -3, 5 be in? Would it be in quadrant 1, 2, 3, or 4? Did you say quadrant 2? Then you are correct. So we're going to do the crisscross. This is quadrant 1. Quadrant 2 is over here. So -3 is to the left of 0 and 5 is above 0. So it would land in quadrant 2. Where would the first point, 4, -2, what quadrant would that end up in? That would be quadrant 4 over here. How do you know? Because 4 is positive and -2 would go down. So you'd end up in quadrant 2. Let me ask you a question. Let me just cover this up for a moment. If I was to say, where would you find point 4, 0 on the quadrant graph? Where would 4, 0 be? Well, 4 is your x value. This is x. And 0 is your y value. So you would find 4, 2, 3, you would find 4 on your x point, and how much would you rise above it or below it? Nothing, right? Because it's a 0. So you would be right on the x-axis. What about if I gave you the point 0, -3? Where would 0, -3 be? Well, your x value comes first, that's 0, and your y value is -3. Find 0, 0's right here, and then y is -3, so you're going to go down 3, and that would be right on the y-axis. So people get confused about those pretty easily. So just know that when y is 0, you're on the x-axis. And when x is 0, you're on the y-axis. So it's just the opposite of what you're thinking. Okay? They're doing the same thing here. They're saying, but now they're saying, well, which one's x and which one's y in this ordered pair? So if you look at this one right here, which point is x? -1 or 6? Right, -1 because x comes before y in the alphabet and x always comes first in an ordered pair. And 6 is your y value. Okay, I think you'll be fine on those. Let's move down. Now they want you to write the coordinates of the points. So let's just do a couple. Let's do point A. So let me highlight that point for you. Right here, point A. Where is point A? Well, first we see how far left or right of 0 it is. We know it's in quadrant 2, so it's going to be to the left of 0, right here. It's at -6. Now we say how far up or down is it from 0? Well, it's up, right? So it's going to be positive, and you go up to where it hits the line here. It's at 5. So the coordinate would be -6, comma 5. Let's try H down here. See where H is here? What's the coordinates of H? Yep, it's to the right of 0, 5 units. So 5. And then it's below 0. How many below 0 is it? Well, let's look. Trace it over to here. It's -2. So 5, -2. So you can try some more of those on your own. Let's move into some of the other stuff. So you're going to get to write all the coordinates of all those letters. And now plotting points on a grid. So more of what we just did. This time they don't give you the points. They give you the coordinates and you plot the points. So point A, right down here, is 2, -3. What quadrant is that going to be plotted in? 2, -3. Did you say quadrant 4? Then you are correct. So find the 2 and then go down, because it's -3, go down 3. 1, 2, 3. And where the 2 points meet, that is where you would plot it. So that's going to be point A. Let's do point B. It's -4, 2. What quadrant will that be in? Yep, quadrant 2. So we go 4 to the left, 1, 2, 3, 4, and we go 2 up, 1, 2. That is point B, quadrant 2. And you can plot the rest of those. And let's move on to the next page. Let's talk a little bit about graphing a line. So a line is called a linear, it has an equation called a linear equation. So this line right here crosses the x-axis and crosses the y-axis. Where it crosses the x-axis is right here, and they call that the x-intercept. And where it crosses the y-axis is right here, and they call that the y-intercept. Notice that at the x-intercept, y is 0, and at the y-intercept, x is 0. So it's just the opposite of what you're thinking. So what is the value of the x-intercept right here? What is the point value for that? What are the coordinates? Well, we go from 0 to -1 to -2. So it's -2. And how high up or down is it? 0, right? -2, 0. Y is always 0 at the x-intercept. And then the y-intercept here is plotted for you, and they tell you it's 0, 2. So it doesn't go left or right at all, but it does go up 2. So the x value will be 0 at the y-intercept. And you can take a look at that on your own and read that up a little bit. I want to show you another thing. Draw a different line. So this line, put this line back for a minute. This line is a positive slope. So if I were riding a bicycle like this, don't laugh at my pictures, they're not going to be great. But I'm riding my bike from left to right, I'm going uphill. And uphill is a positive slope. The amount of the steepness of the slope is going to be given a number. So if it's more steep, it's going to have a bigger number than if it's less steep. So let's say this slope is 2. Just making a guess there. If I was to put another line going, let's make a different color. If I was to put another line going like this, and I was going to bike up that slope or that hill, would my number be bigger or smaller than 2? Yeah, it would be bigger than 2 because it's steeper. So the steeper the slope, the higher the number. Okay, you can also have slopes, let me clear, that go downhill. So if I go this way, let me take a different color here. If I go this way, that's a downhill slope. And how do I know that? I start from left to right and I see what direction am I going. Well, now on my bike, I am going downhill. So I'm going that way. So slopes that go downhill are negative in number, negative in value. So let's say this is -2. The steeper the downhill, the more negative the slope. So let's draw another one going like this. Notice how this is almost straight up and down. So that's going to be a very steep slope. Maybe that's like a -4. Okay, so slopes are given a number, and that's a linear equation that we're talking about. There'll be an equation that goes with that line. Let me ask you a question. What about a slope that goes like this? What would be the value of a slope that goes straight up and down? Well, it's so steep that we cannot give it a number, so we call it undefined. So a slope that goes straight up and down vertically is undefined. And that would have the equation of x equals, and then whatever number that the line goes through. So it's going through 3. So this would be x equals 3, that line. Okay, what about a line that goes completely horizontal? What would be the slope of that line? Right, that line would have a slope of 0 because there is no hill, right? There's no hill at all. So there's no incline. That would be a flat surface. So there's no slope. And the value of this one as an equation would be y equals, and then whatever value the line is going through. So it looks like it's going through 5. So that would be y equals 5. Okay, so you have positive slopes, you have negative slopes, you have a vertical slope, and you have a horizontal slope. Let's go on a little bit here, and they want us to graph the line containing the set of 3 points and find the x and y intercept. So they're giving you the points down here. Here are your 3 points, 1, -3, 3, 3, and 4, 6. So let's plot those. So 1 is 1 unit to the right, and then -3 is 3 units down, and we put our point here. Then we have 3, 3. That's 3 to the right and 3 up. And then we have 4, 6. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. And after you do a bunch of these, you get really good at it. So there, and then we try to connect the dots. If you ever did connect the dots in kindergarten, that was always super fun. We're going to try to connect the dots here. Being that I'm on a computer, it may not be exact. I'll try to, there we go, almost. There we go. Okay, that is our line that contains those 3 points. Now, what is the x-intercept? That is where the line crosses the x-axis. So where does the line cross the x-axis? Right there. And what number is it at? Kind of covered it up. Can you tell? Yes, it's at 2. Now, what are the coordinates of that? Well, what's the x value? The x value is 2, and the y value is 0. Remember, y is always 0 on the x-intercept. So that has the coordinates of 2, 0. Now let's find the y-intercept. The y-intercept is used much more than the x-intercept is when you do these linear equations. So let's find it. So it looks like it's right there at -5. So what are the coordinates at that point? Well, what is the x value? X is 0. Remember that at the y-intercept, x is always 0. And what is the y value? I covered it up. Can you see what the number is? -5. So that would be 0, -5. So that's what you would write here. So then on the second one there next to you, you can work on that one. See if you can graph those 3 points and find the x and y intercept. Let's move on. So finding the slope of a line, there's several ways to do it, and you've probably heard of this before. There is rise over run. That's one way. There is also the change in y over the change in x. And to figure out the change in y over the change in x, you're taking the difference in the verticals, the y, you say y2, that's the second point minus the first point on the line, over the x value of the second point minus the x value of the first point. So those are the 3 formulas for finding the slope. I'll leave those up there, and we're going to slide up a little bit here. So for example, let's use rise over run on this first one here. Let's just highlight this line a little bit better so that we can see it. Okay, here we are. So they picked a couple points here, and I'll make them blue so we can see them again. They picked this point right here, and then they picked this point right here. So we're going to do rise over run first. Since this graph goes up 1 unit at a time, left or right, up or down, we can use rise over run very nicely. So our rise is how far up or down we have gone. So let's make it green, I guess. So we are going to drop down right here to where we're going to be hitting this point eventually. How far did we drop down? Well, we went from 6 down to 2, right? So the change, the rise is a drop of 6 minus 2 or -4. And why do I say negative? Because we went down. If we went up, it would be positive. And then we went, the next step is to hit the point from here to there. So we went from 3 to 1. How much of a change is that? Well, if we go to the left, we consider that a negative change. So from 3 to 1 is -2. Now rise over run. This is your rise. And this is your run. Run is always the horizontal and rise is always the vertical. So it would be -4 over -2, and that would equal, the two negatives cross off, 4 over 2, and then you divide 4 by 2, and you get 2. So this line has a steepness, a slope of 2. Now let me ask you, could I have gone, just change this for a minute, erase this. Could I have gone the other way? Could I have gone from here to there first? Absolutely, that would become a +2. And then I would go up, which would be a +4. So it doesn't matter what direction you go, I'd still end up getting a slope of 2. It's a positive upward sloping line, so it's a positive value. So now let's take a look at what those coordinates were that we just used. And let's see what we're doing. So let's erase the rise over run. Let's try the other formula. We know that the slope is 2. What is this blue point here? Well, that is point 3, 6. And this other blue point here is 1, 2. Now, if I was just given the points and not the graph, and I couldn't use rise over run, or say the graph didn't go up by 1 unit at a time, I can use this formula up here, the change in y over the change in x. So what would I do? I would take the 6 minus the 2, that's the change in y, that's my y2 minus my y1, 6 minus the 2 on the top, and on the bottom, I would do my 3 minus my 1. Those are my two x values, 3 minus 1. So 6 minus 2 is 4, and 3 minus 1 is 2. Notice how I get the same result. Why is that? Well, because I'm doing the same thing. I'm going from 6 down to 2, just like I was before, but I'm not showing it graphically this time. I'm just subtracting it, 6 minus 2, which is what I did when I graphed. But if I don't have a graph, I can use that formula. So that's another way to find the slope. Okay, so you get an opportunity, I believe, coming up here. This talks about the zero and undefined slopes and the types of slopes, the positive and negatives, and the y and the x-intercepts. So we talked about all that. Now they want you to actually find the slope in number 3. Not only do they want you to find the slope, they want you to find the x-intercept here, and they want you to find the y-intercept right in here. So finding the slope, you have a couple of options. You can do rise over run, like we just showed you. You can either go left and then up, or you can go down and then right and do rise over run. Notice, what is that value of that slope? Is it going to be positive or negative? Right, it's going to be negative because it's going downhill. If you don't want to use rise over run, you can use the y2 minus y1 over x2 minus x1. So y2 could be the 6 and y1 could be the -2. Would it matter if you chose this -2 to be y2 and this 6 to be y1? No, in the end, you'll get the same answer. Because remember, we can go down and to the right, or we can go left and up. So it's not going to matter. So if this is y2, this has to be x2. And this has to be x1. And then we calculate. So y2 is 6. y1 is -2. Be very careful. It's minus -2. And then on the bottom, if we paired the 6 here, we got to pair it with its buddy, -3. That'll be our x2 minus 3, our x1. Be very careful on these minus signs. So what is 6 minus -2? Well, that's really 8, isn't it? It's like adding. The two negatives cancel each other out. -3 minus 3 is the same as -3 plus -3, which is -6. And then we reduce it. So 2 will go into 8 4 times, and 2 will go into 6 3 times. So -4/3. And didn't we say that it's a downward sloping line? So it should be a negative answer. And we can keep it as -4/3. Usually with slope, you can keep it as a fraction if it looks like this, because then you can see the actual rise in the run. And then your x-intercept is going to be where? Let's change colors here. Your x-intercept is going to be right here. Where's your y-intercept? Right there. So you have to tell what those coordinates are. Remember, at the x-intercept, y is 0. At the y-intercept, the x point is 0. You get to do that on number 3. On number 4, you get to not use the graph, but use the formula, the change in y over the change in x, the one we just used, y2 minus y1 over x2 minus x1. And they give you 2 points, and they want you to find the slope. Now, graphing a linear equation. There's several ways of doing this. A linear equation or a line is shown by a formula that looks like this. It can take various forms. That's the common point y-intercept form. There's also the point slope form, and then there's the standard form. For the most part, you're going to be using this format. So y equals 3x minus 1. Each one of these things means something in the formula. So y equals mx plus b, or mx minus b. That's the standard format. M is your slope of your line, and b is the y value of your y-intercept. It's called the y value of your y-intercept, because the x is 0, right? So we're only caring about the y value there. So we can look at our equation right here, and we can say that the slope of this line is what? What's the slope of y equals 3x minus 1? Well, y equals 3x minus 1. The slope is 3, and the y-intercept is -1. Knowing just those two things, we can graph the line. We can graph it because with 2 points, you can connect the dots and make a line. So we're going to plot the y-intercept first. The y-intercept we said was -1. So we're going to go down here, and we know that at the y-intercept, x is 0. So we're going to plot -1 right here. It's already there for us, but we're going to show you how this is done. And then we know that our slope is 3. Technically, we can put the 3 over a 1 because that's still 3. And we need to do that for rise over run. So we're going to put a 1 under our 3. It's not changing anything. It's not changing the value. So this means to rise 3 and to run 1 from the y-intercept. So if I go, change colors here. If I'm at the y-intercept, I'm going to rise 3, 1, 2, 3, and I'm going up because that value is positive. And then I'm going to run 1 to the right. That's why I put the 3 over a 1. And I'm going to go 1 to the right here. So I rose 3 and I ran 1. And because I went up, that's positive, and because I went to the right, that's positive. And then I put that second point right where I landed. And then I can connect the dots. Different color here. I can just connect the dots here, just like that. So that's one way to graph a linear equation. They give you the equation. Let's say they didn't give me the equation. So let's clear. If they didn't give me the equation, and let's say well, actually, this example is giving you the equation. So let's just say we didn't know that y equals mx plus b thing. But we can plug in points and choose points. So let's say I plug in a 0. So I'm going to plug 0 in for x, and I'm going to solve for y. So 3 times 0 is 0, minus 1 is negative 1. So at x equals 0, y is negative 1. Let's say I'm going to plug in 1 for x. So 1 is going to go for x. So 3 times 1 is 3, minus 1 is 2. So at 1, the value is 2. Then let's try 2 for x. We plug in 2 for x. We get 3 times 2 is 6, minus 1 is 5. So at 2, the value is 5. So we can also plot the graph by plugging in values given the equation. So we have 0, negative 1, and that we know is the y-intercept. Then we have 1, 2, so we go 1 and up 2. And then we have 2 and then 5. So 2 and up 5. And here we have 3 points that lie on our line. So we can then graph our line. We only need 2 points, but we have 3 in this case, so that's great. We'll put them in there, and there we go. That's another way to graph the line. Okay, let's see what they want you to do here. They want you to they want you to plug in the values. Graph each equation. As a first step, complete the table of values, then find the x and y intercepts and the slope. So you're going to plug in a 0 for x, and what value for y do you get? 0 minus 2 equals negative 2. So there would be your first point that you're going to plot, 0, negative 2. And then you would plug 2 in and figure out what the y value is and plot that point. And you would plug 5 in and see what the y value is and plot that point. And then you would graph your line by connecting your dots, whichever way they land. And then you would find your x-intercept, your y-intercept, and your slope. To find your slope, you can use several methods that you know now. You can look at the equation right here, and you can say y equals mx plus b. The number in front of x would be your slope. Well, there is no number in front of x, but remember, with a variable, there's always an imaginary 1 in front of a variable. And you could also find your slope another way by doing y2 minus y1 over x2 minus x1. And where would you get your points? Well, right from your table of values here. Another way is to do rise over run. How could you do rise over run? Well, you plot your 3 points in your line, and then you see how much you rise from one point to the next and how much you run from one point to the next. So you have several methods now for graphing lines. So this one, they have you do this again for number 2, and then they want you to do the x and y intercept and the slope, and again for number 3, and again for number 4. So there, so that is the end of this packet. So good luck, and we'll see you at the next session. Bye.